Welcome back, students. During this class, we will study some of the most important topics of the capacitors, and these are to calculate capacitance of the capacitors when they are combined in series, and the next one will be when they are combined in parallel combination. So, if you look at when the capacitors are connected plate to plate, such that so that each capacitor will have the same amount of charge stored, then it is called series combination. So this type of combination which you are looking is a type of combination which is called series combination. So here it is. Take the point, highlight. Yes. If you look at this is the concept of para, series combination of the capacitors. Capacitors are connected plate to plate. Here it is, plate to plate. This type of combination is called series combination of the capacitors. Plate to plate, they are connected so that each capacitor have the same amount of the charge stored. Then it is called series combination. So I'll discuss how the same amount of charge will be on each capacitor. Consider capacitor C1, C2, and C3. These are the three capacitors are connected in series. A battery of voltage V is connected between A and B. Here is A and here it is B. So then it supplies positive charge to left uh, plate of the capacitor and negative charge to the right side of the plate. As a result of this charging, each capacitor will get an equal amount of charge Q on each of its plates. So here it means that the amount of charge on Q1 and amount of charge on Q2 and amount of charge on Q3 capacitor will be the same. All the capacitors have the same amount of the charge. It means that if one positive charge comes here, deposits on this plate, it will repel the other positive charge from the other plate. This positive charge will move to the other side of the plate, and by this way here it will be the positive charge. Again this positive charge, same positive charge will repel the other positive charge under this plate, and this positive charge will move to the other side. So here it is. If you look at, this is the positive charge. So again this single positive charge will repel the other single positive charge, and by this way a one charge entering from one of the plate has resulted in a single charge exiting from the other side of the plate. So it means one charge has electrostatic force of attraction over the other, and similar sequence of the repulsion and attraction of the forces is applicable to all the plates which are connected in parallel to in series with either each other. So this is a type of combination called series combination. Single charge enters, single charge exits, reaches at this plate, does the same which it has done in the first. So again it is repeated when it leaves to the other last plate, single charge is there. It means this in this type of combination of the capacitor, each capacitor will carry same amount of the charge, single charge, single pair, single. So this is the reason why it is said that in case of plate to plate combination, the capacitors are carrying same amount of the charge. Same is in the case for this charge. This single charge enters here, electrostatic process takes place, it moves to the other side of the plate. So same single combination electrostatic process, and at the end same electrostatic process takes place, and by this way the charge reaches to the other side of the plate. So due to this reason, each plate is carrying same amount of the charge, one charge and one charge, plus one, and similar is the case minus, negative, negative, and negative, single charge. So amount of charges is stored on plates in case of series combination is the same. But if you look at when the charge enters from this plate, it uses some amount of energy and then it moves to the other side. from moving from one capacitor and reaching up to the last capacitor, some amount of energy is consumed. So that's why the potential will not be the same when the charges are moving from one plate in case of parallel combination. And this process takes on at the last one. So that's why the potential across each capacitor will be the different. And the potential which you have applied from the battery, it is divided in all three types of the plates. So potential across plate 1, potential across 2, and across 3, plate 3. So these are the capacitance of all the capacitors which are connected in series. Capacitance potential across capacitor 1, capacitor 2, and capacitor 3. It will be added. To the other side, the total amount of energy will be consumed by all three types of the capacitors to store charges. And the amount of the charges is stored on the capacitors. So here it is V1, that is calculated by Q divided by C1, and Q, because you know that Q is equal to CV. This Q is equal to C and V. So if it is charges are same, then capacitance is the different C1, V1, and this V1 will be equal to this one. And similar is the case, then if it is Q, that is equal to C2 V2, C2 and V2, then you are calculating V2, it will be equal to Q divided by C2. Here it is Q divided by C2. And similarly, it will take place in case of V3, that will be Q divided by C3. If you add the values of V1, V2 in equation, this one equation, then you will be getting that is V is equal to V1 plus V2 plus V3. Putting the value of V1, V2, and V3, you are getting this one. If you take the Q common, so it will be 1 over C1 plus 1 over C2 plus 1 over C3. What was your object? To calculate the capacitance of the capacitors, total capacitance of the capacitors when they are connected in series combination. So let's see E be the capacitance of the equivalent EQ or the E capacitors, then which would hold the same charge and the potential difference V is applied. So Q, that is equal to CV, and basically if it is equivalent capacitance, then it will be C is equal to Q divided by this. C will be equal to Q divided by V. So if this one is C, that is equivalent, it will be equal to this one. So comparing these two, one, if this one is 3, if you compare these equations together, you will be getting the equivalence cable, this one. So comparing these two, you are getting basically formula for equivalent capacitance, 1 over C equivalent, that is combination, sum of capacitance of all the capacitors connected in series. So what it means, and it's in series combination of capacitors, the reciprocal capacitance of equivalent capacitor is equal to the sum of reciprocal of capacitance of individual capacitors, which also show that in series combination, the equivalent capacitance is always less than the individual capacitance of the combination. So if there are n number of the capacitors which are connected in series combination, that can be written as this formulas up to 1 in case of 3, but if there are nth number of the capacitors, then it will be equal to plus dash dash equal to 1. And in mathematics, to sum up the capacitors up to nth value, we use some shortest type of the techniques to represent. That is, if this I is equal to ith capacitor, that is up to equal to n. So I is equal to n, I is equal to 1, starting from 1 and reaching up to n, this one, this is the summation sign, and it is equal to 1 over Ci, means it is written like this. If this is the capacitance, 1 over capacitance, and if it is ith capacitance of the capacitors up to ith, then this I is basically equal to, its value starts from 1 and its value starts equal to up to n. Its range is up to n. Nth capacitors which are connected in series combination, their equivalent capacitance can be calculated by using this formula. So this is basically equivalent capacitance, EQ equivalent capacitance. So this equation represents the equivalent capacitance due to the combination of nth number of capacitors in series. So let's move back and see the main steps what you have done. Basically, this was the concept, basic concept of calculation of capacitance in case of series plate-to-plate combination. Number of charges on each capacitor in case of series combination will be the same. That is Q1, Q2, Q3, Qn is equal to Q number of the charges. But the potential will be different across each of the capacitors because when the charges will move from plate A and reach up to point B, they will use some amount of energy. Some amount of energy is used to overcome to electrostatic forces and also to during their motion and to overcome the resistive forces. So potential are different. So what will be the potential if this potential is V1, this potential is V2, and if this potential is V3, then the potential will be equal to, then this potential will be equal to the sum of potentials of all the capacitors connected in series. That will be uh, equal to V1 plus V2 plus V3. So sum of after V that will be equal to this one. So after putting the values, you have calculated this one, and this is basically technique to calculate the equivalent capacitance. And after putting the values, you reach up to a point where you are going to calculate some of the equivalent capacitance of all capacitors which are connected in series. So here you have calculated. This reciprocal shows that the capacitance of the capacitors, uh, individual capacitance is less than the capacitance of a single capacitor. So here it is for the nth number of the capacitor. How will you calculate capacitance? Capacitance. This is the formula added up to nth capacitors, and it is written like this one. The capacitors are starting from 1 and ending up to nth number of capacitors are added, and this is the summation which shows that the total capacitance of all the capacitors can be calculated by using this technique in case of series combination. I thank you very much for your patience. Hope you people have understood. I thank you all.